All right, let's start. Welcome at the LF Energy Summit 2024, the last presentation of the first day. We know we are in between you and a cold drink, so we hope there's some LF Energy left. All right. Welcome at our presentation about GXF, the Grid Exchange Fabric. It's a building block within the ecosystem of LF Energy. And with GXF, we bridge the physical world and the digital world. At the beginning of the day, Mark and Savannah, I hope I'm right about that, highlighted the need of data for data sheets and to manage the energy network. And of course, data is also very important to guide us through the energy transition. And one of our products is data. A warm welcome to everyone. My name is Maarten Mulder, and I've been working in the energy sector for almost 20 years. And I became product owner at Alliander for the field device platform team in 2020. And together with approximately 15 developers, we work on GXF and common applications. One of these developers agreed to join me in Brussels to share his experience. Jelle.
Yeah, my name is Jelle Hoffman. I'm a Java DevOps engineer at Alliander. I've been part of the team of Maarten since 2020. And I've learned, I think, a lot about the grid operators in the last 4 years. Challenges are basically the same, like generating data. But every grid operator or distributed system operator takes its own path and chooses its own solutions, and on a technical level. But in the end, the challenges are still the same. And I work at Alliander because of a social responsibility commit. I don't want to work like for an HR software giant. I want to be socially committed to, in this case, the Netherlands, and ultimately for LF Energy. So that's why I work at Alliander. That's me.
Thanks, Jelle. Today, we would like to tell you something about our company. We work for Alliander. We will explain the purpose of GXF, the Grid Exchange Fabric, and focus on different use cases we applied by using this building block, GXF. We are going to tell you also something about the current architecture and our future direction. Jelle will do that. And finally, there's some time for questions. Alliander is here with several projects. So many of you have seen this introduction, I think. So I will keep it brief. Alliander is also known in the operations as Alliander in the Netherlands. We are the grid operator for 1/3 of the Netherlands. And the Netherlands, you can see over there, is a small, compact and complex country with 18 million inhabitants. And together with Tenet, GasUnie, Enexis, Stedin, we manage the energy network, one of the most reliable networks in the world. Alliander is growing due to our mission to keep energy accessible and available to everyone. This is a significant challenge due to congestion and also the energy transition. Currently, nearly 10,000 people work together with us at Alliander, and we are still looking for talented colleagues. if you are interested. We'd love to hear from you. Then, the Grid Exchange Fabric. As I mentioned in the introduction, the Grid Exchange Fabric is a building block that bridges the physical and the digital worlds. In other words, it's a communication platform between devices or hardware in the field, and these communicate with the central applications. With various protocols, we can collect monitoring data and alarms, and for example, light sensors over there at monitoring. We can also get congestion data, fault detection, and a lot of other things we can arrange. We also send control signals to devices, that's the other side, the steering side, such as turning public lighting on and off. We will tell you more about that when we talk about our use cases. But also uploading schedules, making firmware updates, etc., etc. And we send those information mostly to RTUs. The platform is open, meaning no logins. We use standards and open source technology, so there are no surprises. It is generic enough to support a wide range of use cases, and we will demonstrate these afterwards. It's independent, and it allows you to follow your own roadmap and make independent additions to the platform. And of course, we prefer to collaborate with you on new developments. It's scalable. The platform has already proven itself in production, and we will discuss that during the use cases shortly. And we will demonstrate that afterwards. Then the start of GXF. I don't know if you can see that. In 2017, the project started as OSGP. In 2012, excuse. There was a separate entity of Alliander. And in 2017, OSGP was reintegrated into Alliander. And then it was creating its first chain, where we start with public lighting. That was the first business value we delivered. And also associate applications we used over there for public lighting. In 2020, OSGP became part of LF Energy. And then we changed the name to GXF, the Grid Exchange Fabric. From that moment, we continue developing various use cases within Alliander. For instance, in 2021, the smart meter head-end was added. Then we quickly realized that congestion issues needed to be made visible, and this was leading to the first low voltage measurements being integrated into the platform in 2022. That's in the middle. In 2023, we transitioned into containers, and all smart meters of Alliander were added to GXF. And the latest development is the standardization of hardware. There we use gateway devices, a battery-powered one, and one with edge computing. And this is the basis for several new chains and also integration of IoT devices. Now I'd like to tell you about the first chain we add to GXF, and that is flexible public lighting. In the Netherlands, this is a legal responsibility that must be carried out by the grid operator. And we are responsible for 1/3 of the Netherlands. And here you can see all the devices we talk with GXF. Red is not good, of course. There is a communication issue, but the nice thing about that is that the devices works autonomously. In Dutch we call it autonoom. We communicate with 20,000 switching devices, and that's a Kaifa and Elster device. And to perform these functions, we developed 2 applications on top of GXF, because we are a communication platform, but to send steering messages to the devices, we need to have applications on top of the platform. And one of these is the installation app, and that allows technicians to install new devices. And we also have an operator app that allows administrators, technicians and users to perform functions such as switching the lights on and off ad hoc. The next chain is smart metering. All Alliander smart meters are connected to the platform. We are talking about 6 million devices, electricity and gas. Together these generate over 10 million events every day. At the platform's lower level, we communicate by CDMA, LTE-M and GPRS. Other grid operators in the Netherlands will likely adopt the platform as they transition to a new modular system. This would mean adding million more devices. This demonstrates that GXF is a scalable solution. The platform handles events to and from devices, including the meter reads, power quality data, firmware updates and configuration changes. A hardware security model has also been implemented to ensure secure process handling, and in short, this platform is scalable, secure and provides fast processing. Jelle.
Yeah, I'm going to go more into detail on the technical side of the GXF platform, but before I do that, I want to know who here has heard about GXF before today. Please show hands. Yeah. Perfect, nice. Who here has heard it from today, before this presentation? Okay, yeah. And who here has checked out our code on our GitHub repository? Yeah? Yeah, sometimes, yeah. What did you do with it? What did you look at?
Specifically diagrams and any other documentation that I could find.
Ah, okay. Not a specific use case that you wanted to see if it could work with GXF, or?
Yeah, I was checking for a different project outside of this conference. I was checking to see if we could leverage GXF for ingesting measurements, but also grouping measurements on multiple nodes together into groups. I was checking if that was possible, but it didn't seem to be completely possible.
Yeah.
Almost possible.
Yeah. Yeah, almost possible. I think that's correct. Yeah. Okay, nice. Good to know. Good to know. Then I'm going to talk on the current GXF platform, which is currently known within the LF Energy company exchange foundation. I should say. It's mainly known because of its open source repository, open smart grid platform. And that's still a link to our past, the old name in 2012. This repository is capable of the public lighting and smart meter heading switching events. However, it's quite an old application, 2012, for software development. That's quite old. So by now we have a bit of legacy that is in our code base, and we know that, we understand that. It's also a quite big code base, so it's difficult to collaborate with developers because there's a really high cognitive load needed to understand the software behind the platform. And it's also a layered architecture. I won't go into detail how it works, but what you can see on the right side is at the bottom there are protocols that are energy sector specific, like ESA 104 for light measurement devices. 6185 is for the public lighting, but we also support MQTT as a more basic generic protocol. And it goes through those protocol adapters basically through to a core layer, and then it goes to the specific subdomain, so the specific use case. And then we can return it through the user to the application integration layer. The downside of such a layered architecture is that you have we have multiple containers. Like for example, we have a container that does the protocol side of things, but for this layered architecture, all the things that are presented here need to be in place, and they need to be running. In that way, it's a request-based platform, and it's a layered architecture. And we know that we need to change some things to, like, also create an open source community, but also for ourselves to not have the big like the high, I need to say it correctly, the high cohesion, low coupling, meaning the high cohesion, not everything is done within one single service, and the low coupling, meaning services depend on one another to perform a process, basically. And we have been thinking in the last few years about the GXF 2.0, but before I'm going to talk about that, there are a few more use cases Maarten would like to present that already work on that new platform.
Yeah, one of the new change is the low voltage measurement chain, and it provides insights into congestion data. Our goal here is to measure this for the entire Alliander network. We are measuring the outgoing electricity fields from the transformator using Rachowski coils. By the end of the year, we will have that connected for 8,000 devices, measurement devices. And the data is valuable for different projects, for example users, network calculations, but also forecasting, controlled connection of new customers, and even detecting energy fraud. Then the next chain, like I said, we need to standardize also on the hardware side, and this is a battery-powered RTU. With this battery-powered RTU, we can connect new different chains, like the cable oil pressure chain and cathodic protection. Yeah, these are necessary to stay in control of our energy network. And also, fault detection was a possibility, but the news is that we decide not to add that one and solve that on another way. Then we've got the, we call it the MSR gateway. In addition to the battery powered device, we're also developing a gateway device with edge computing capabilities. This standardized device will be deployed in the medium voltage space. On the right hand side you can see the RTU. All digitalization solution will be connected to it in the medium voltage space. including the previous mentioned solutions like public lighting and low voltage measurements. IoT applications such as temperature measurements and door sensors can be connected as well. And we will deploy this solution in 30,000 medium voltage spaces over the years. Then Jelle, GXF 2.0.
Yeah, GXF 2.0. There are a few key differences in our opinion between the last 3 use cases and the first 2. For example, public lighting and smart meter headend, those involve quite a lot of user interruptions. Basically, users are able to change the state of a device. For example, for public lighting, a government, a municipality, difficult English word, but a municipality is able to change the light schedule of public lighting, meaning that they can change when the light turns on for some reason or whatever. And those last 3 use cases are, in our opinion, more data streaming use cases, meaning that you have a device, you have a RTU, and you install that in a medium voltage space or anywhere else in the field, basically, and you install it, and that data needs to be transformed, and then it can be put into the organization, in our case Alliander. And those use cases, they ask for a different architecture, more service-based architecture. And as you can see on the right side, this is the quick and simplistic architecture for low voltage measurement. Basically, an RTU sends an MQTT message to an internal Kafka bridge. Basically, that maps the MQTT message, puts it in a Kafka message, and it gets sent on the Kafka bus. Well, 1 second, I will get to your question. And then from that Kafka bus, it goes into a measurement processor that is solely responsible for, as the name implies, processing the message. So it transforms the data. It adds, for example, the name of the medium voltage space house and the address where the measurement has been done by the RTU. And that enhanced data is then put back on the Kafka bus, and it can be used by teams that use the data to, like for example, Maarten said, fraud detection. But it can also be used in our case as in a Grafana adapter that puts the data into an InfluxDB, and that InfluxDB is coupled to Grafana. And that Grafana dashboard is for technicians to see, okay, what are the voltages in a medium voltage space for each different phase, for the 3 different phases. So this is basically the main architecture, but it has different principles. It's a service-based architecture. Each service, we don't want to talk about microservices, but a service is responsible for one single thing, and that way we want to enable the high cohesion, so the single responsibility principle. And through using Kafka, we have a low coupling. And if one of the services is down, then the other services can still run and do their job, even though one service is down. So you don't have the layered architecture anymore. Maybe, did I answer your question? Okay, perfect. And as I said, it's right now the open source as well as the closed source repository. It's quite big. It's a big monolithic repository. And what we want to do is for each service make a different GitHub repository. Also to enable more collaboration, to have a lesser code base, smaller code base for collaborators to be able to get started with our code as a maintainer. And this service architecture is also event-driven, meaning the old architecture is more based around requests. So it asks for a status of a device, then it gets a return value, and that's the current status of a device. And event-driven means basically that the RTU, in this case, says, okay, this is the current state, and what you do with it, it's not my problem, but this is my current state. And then other applications, other services can use that information to update their status and do some extra business processing that they need to do with that information, with that specific information. Yeah. Yeah, and if we're looking at GXF 2.0, then it's also a good opportunity to do some technical improvements. What we are doing is we're going from Java to Kotlin, because we think Kotlin has definitely on the boilerplate side of things has a few key benefits. We're going from ActiveMQ to Kafka because the ActiveMQ is not widely used within the software development world. Kafka is more used, and more users means more opportunity to collaborate. And also Kafka is more used within the Alliander infrastructure. So it is a good choice for us. The APIs that were built in 1.0 were all SOAP UI. SOAP UI definitely has its benefits on a security level. But REST API, again, is more widely used within the IT world. So that is why we're going with REST API. As I said, we want to try to be event-driven. So REST APIs are a last call. Kafka has has a higher priority, basically. So if we need to make a REST API, then it would be a REST API instead of a SOAP UI. Also, we're going from Maven to Gradle. That's more for us internally as maintainers, also for the closed source part. Gradle has a build cache, basically meaning that we have much faster builds. We're running into the problem that our builds are quite slow because of the big monolithic repository. And also, we're going from Jenkins to GitHub Actions. GitHub Actions has more support, is open source, can be shown within the GitHub repository, and is also quite easy to make the Docker containers available through GitHub packages. So that's where doing all these technical improvements.
Perfect, thank you.
And then the last part about GXF 2.0, the current status. As we shown today, we have a lot of use cases going through the platform. And FlexOVL, so that's public lighting. The backend is still in 1.0. However, the front end is in 2.0, but it's still closed source. Smart meter headend is also still in 1.0, and Open Smart Grid platform, the open source repository as well. And what is currently in GXF 2.0 is the low voltage measurement chain. The complete chain is written in the principles of GXF 2.0, and also battery powered RTU. It also stands for standalone notifying gateway. And it's partly open source and partly closed source. And as you can see on the right side, that's the current repositories that we have that are public, written in Kotlin for the standalone notifying gateway. We want to move everything to GXF 2.0, but yeah, it takes some time, and we want to make everything open source as well, as much as possible, but that is also going to take time to implement these new principles. Yeah.
Yeah, then the next steps. At this moment, we are in the early adaptation stage. And I think that's the right stage for us. When we want to move forward, we need to have more collaboration on the platform. We have the silver badge, the best practice badge, and collaboration with other parties outside Alliander. That's where we're looking for. Then we've got community improvements, also based on the steps Jelle told about to GXF 2.0. An easier startup we have to create, and to start up containers, that's more easy than using the old code. So that is what we arranged in the last period. We are expanding the possibility with smaller services, as Jelle mentioned. And furthermore, we want to simplify the platform by using the containers I told about. We want to make it more plug and play. So also the applications which are closed source, we want to make open source. And we can fill in our roadmap up until 2026, because we've got still a lot of work to do. And we will work that out in the roadmap which you can find. And then the next slide.
Yeah, if you want to know more about GXF, please look at our GitHub repository, or organization I should say. Read our documentation, view our website, and you can also email us. And if you want to connect on LinkedIn, on the right side we have some QR codes, maybe as well. And I think that is it for now. If you have any questions, then please raise your hand. Not all at once. Yeah?
I have two questions. The protocol that you choose, does it have like defined semantics ontology, the way the communications are made? Because you say you communicate QTT, you change it to Kafka, then after you use Kafka, yeah, but you change the ontology or semantics that you use the message transmission. You define it yourself,
Yeah.
or you base it on something else?
Yeah.
Is that something about the project that you define the text on?
Yeah, basically when we implement a new use case, like low voltage measurement, the Kafka message is determined before we implement the use case by our architects within the GXF project, but also within Alliander. And we have like a SIM compliant Avro messages, basically meaning that Avro message is capable of interchanging between grid operators. So another grid operator could take that Avro message and use it within their own organization. I think maybe that answers your question. The MQTT side of things, so the RTU side, that is quite specific for that device. And what we basically do as a GXF platform, we are the first step into an organization. In this case, for Alliander, we transform the data, and then other parties within the organization can create the actual business value, basically.
I have another, maybe more philosophical.
Yeah.
Data is only going to grow over time.
Yeah.
According to this,
Yeah.
tomorrow.
Yeah.
And cost the transmission and measuring every single point is going to be more complex over time. So I think like hierarchical architectures in which you aggregate data to a certain level after communicate, like, I don't know, aggregate your whole neighborhood or whatever.
Mm-hmm.
Do you see this in the roadmap somehow to reduce the amount of data transmission to the cloud?
Yeah. Yeah. Most definitely, that is the MSR gateway, so the medium voltage space gateway device that is installed there. That also has edge computing capabilities, so you can run Docker containers on that device. And also the plan is that we run GXF on that device itself. And there, most definitely, you can do compacting. Okay, this data won't be transferred to the organization, and this data is going to transfer to the organization. But I have to say that is that's on our roadmap. That's not where we are right now. We're coming to to that part, basically.
At this moment, our historian is really booming.
Yeah.
Of course. So yeah, we have to work on that. Yeah.
So one question I have is that scale, sort of building on that question. You're doing the ETL you're going through Kafka queues, you're doing data transformation as part of that. One of the things in managing a grid at a very high level is going to be almost a data lake of information and AI analysis of a lot of that stuff to derive the insights for the management of the stability of the whole grid.
Yeah.
As opposed to the individual data streams from the RTUs that you might feed through it and transport.
Yeah.
How are you approaching? Because that's obviously something I don't think anyone's got substantially under their belt yet.
No.
But it is clearly in everyone's roadmap. What's how do you approach that issue? That problem of very large data sets that then need to be to make new sense of them. You have to have an AI approach to analysing those data sets to make stability decisions, operational decisions. Is that part of your roadmap?
No.
Nope.
Because basically the GXF is a transformation platform, a communication platform. I think there's a lot of talk, as Maarten said today, about data. But before you can talk about data, you have to create the data in a generic way that everybody understands. And that is basically what we are trying to do. And yeah, no, we are not part on the data storage and yeah, definitely. Yeah, if more open source and also looking at more projects within LF Energy. Yeah, definitely. That's definitely on our mind.
There are already projects who are using information about low voltage measurements, for example. So we deliver data and functions, and then it's for other parties to do nice things with that. Yeah.
Thanks.
Other questions? One more?
No, that's not correct.
No.
So the GXF 1.0 has both ways. So it's built in both ways. So public lighting and smart meter head-end are built both ways. Meaning that users, technicians, operators, everything like that, they can change the state of a device through a application. They switch, okay, lights on or off, basically, and that is communication that is coming from a application through a device. So that is both ways. With the new use cases, the more data is coming downstream than upstream, but still we have upstream capabilities. There is a possibility to set a MQTT message for low voltage measurement saying, okay, you need new firmware with this and this version. But that needs to be a different service, and that is where I think the most work is for us, is turning the old architecture in a service architecture, and in such a way that it makes sense for somebody that has never seen GXF, that understands, okay, if I want to, for example, update a firmware, then I have to go through this firmware service or firmware update service or something like that. But that is something we still need to draw out and think about, basically. Okay?
Risk profile for downstream and upstream is quite different.
Yeah.
So that's something that you need to build into the architecture.
Yeah, definitely.
That's correct.
Also, yeah, great point. Okay, I think that is it.
Thanks a lot.
Yeah, thanks a lot.
Bye.